So exam 2 solutions. Let's quickly solve this for you. So question 1 is actually asking you to find probabilities. Let's take a look at the question. Question says, in a survey of US men, the height in the 20 to 29 age group were normally distributed with a mean of 69.4. So the mean is given to you, 69.4 inches, and standard deviation is 2.9. Find the probability of randomly selecting the study participant with having the following information. Okay, perfect. So the first one says less than 66 inches. Less than 66. The second one says between 66 and 72. Between 66 and 72. C, it says more than 72 inches and identify any unusual events. More than 72 inches. So let us get back to the board and solve this. Very well. So you have the mean, you have the standard deviation. You're randomly selecting one person. This one says, what is the probability that X is less than 66? What are we going to do? We're going to use our calculator. Normal CDF. With lower limit, a negative number, like negative 100, and upper limit, which stops at 66. The mean is given 69.4 and standard deviation is 2.99. So what would be the probability? The probability is equal to how many percent? Almost 12%. Very well. It's not unusual. Why is that? It's not less than 5%. How about the second one? It says find the probability that X is bounded between 66 and 72. Again, we're going to use our calculator, normal CDF. Your lower limit in this case is 66. Your upper limit in this case is 72. The mean stays the same. Standard deviation stays the same. And we do the calculation. We get 69%. Almost 69%. Very well. And here you have more than 72. We're finding the probability that X is greater than 72. Very well. Again, we're using calculator, normal CDF. Our lower limit is equal to 72. Our upper limit is a big number, like 100, 1,000. Then we calculate this probability, which is just 18%. Approximately 18%. None of them are unusual because none of the probabilities or areas are less than 5%. We're good with all of them. So question 2, another probability for you. It says the amount of time per workout an athlete uses a stair climber are normally distributed. Use a mean of 20 minutes. So we have to change this. Let me write down the information on the board. Mean is 20. With standard deviation equals to 5 minutes. We want to find the probability less than 17 minutes. So let's just calculate each. Let me write down this information on the board for you. And we get back to the board. 17 And the second one is in between 20 and 28. And the last one says more than 30 minutes. More than 30 minutes. So let us take a look at our board. So less than, in between, and greater than. Since we are finding the probability and we have the information that we know that our population is normally distributed, we have mean is 20, standard deviation is 5, less than 17, we are finding the probability that x is less than 17. So by using our calculator, normal CDF, our lower limit is negative 1,000, negative 100. Our upper limit stops at 17. If we do the calculation, we get probably like 27%. Between 20 and 28, 20 minutes to 28 minutes, your lower limit is now 20. Your upper limit is 28. So if we use our calculator, it gives us 44%. The probability is 44%. And finally, more than 30 minutes. Okay, more than 30 minutes. It means that your lower limit is 30, your upper limit is 100, 1,000. If we do the calculation, it gives us almost 2.28. Well, 2.28%. It means that this percent is less than 5%. So this is unusual. So you can write since the probability is less than 5%, it is unusual. So let's take a look at question 3. Question 3 says, well, the amount of time Facebook users spend on the website each month are normally distributed. With a mean of 6.7 hours, so let's write down these here, 6.7 hours, with standard deviation of 1.8 hours. Well, part A says find the probability that one Facebook user spends less than 4 hours. Less than 4 hours, so let's just change these. B, probability that Facebook user spend more than 10 hours. More than 10 hours. And C, out of 800 Facebook users, how many would you expect to spend between 2 to 3 hours? Between 2 to 3 hours, then out of 800. Let's get back to the board. Very well. So the probability that less than 4 hours, this is the probability greater than, let me erase this, and in between, less than 4 hours. The second one, the probability of X more than 10 hours. And here you have the probability in between. They spend between 2 to 3 hours. So again, we are using normal CDF. For the first one, the lower limit is negative 100, negative 1,000. Upper limit is 4. Then for the second one, the lower limit is 10. The upper limit is 100, 1,000. And for this one, the lower limit is 2. The upper limit is 3. By doing a calculation, we get 6.68%, almost. It's not unusual. The second one is 3.34%. It is unusual because it's less than 5%. And here you have 0.0154. which gives you 1.54%. Okay, perfect. Out of 800 of them, you know that the probability or the area or the proportion is 1.54% or 0.0154. You multiply that by 800 to get the total number of people, users, who are spending time between 2 to 3 hours a month using Facebook website. 0.0154. So how many do we get?
Yes.
Yes, thank you. Question 4. Okay, the figure at right is from a survey of 498 US adults. This is very similar to the example that we did in class, but I underline this are not the more dangerous drivers. So you want to construct a 99% confidence interval for the population proportion of US adults who think that teenagers are not the more dangerous drivers. Let's write down the information on the board. This is question 4. So our goal is to construct Our goal is to construct a 99% confidence interval. So C is 99% confidence interval, and your N is equal to 498. And the proportion are not dangerous drivers. P hat is 25% plus 4%, which is 29% are not. It means that the rest of them are more dangerous drivers. Okay.
Also, P hat is 0.25 and.
So how do we construct our confidence interval? We have to follow our steps. N is 498 and P hat is 498 times 0.29, which is greater than or equals to 5, and Q hat, which is 498 times Q hat is 71%. So 0.71, which is greater than or equals to 5. Now, C is equal to 99%. 99%. What is our critical value? 2 points. What's your critical value? 2 points.
575.
575. Thank you. This is your ZC. Well, what's the margin of error? The margin of error is equal to ZC times square root of P hat. Q hat divided by N. So confidence interval is equal to P hat minus E, P hat plus E. What's the margin of error that you have? Margin of error.
.23 at 23 and to 0.342.
What's the margin of error? Margin.
Sorry. Margin of error is 0.052.
5252. Thank you. Since all of these they have, let me see, 2 decimal places, so we can leave it as 2 decimal places. So 53. This is good. 0.05. Now P hat is just 29%. So it's 29% minus margin of error and 29% plus margin of error. Okay, if you do the calculation, it's almost 0.24 and 0.34 approximately. So we are 99% confident that the proportion of US adults who think that teenagers are not dangerous drivers are in between 24% to 34%. Let's take a look at question 5. Question 5 says, assume the population is normally distributed and construct a 95% confidence interval for population mean and interpret the result. In a random sample of 8 people, the mean commute time to work was 35.5 and the standard deviation was 7.2. So let's write down this information on the board. We want to build a confidence interval with confidence level 95%. Very well. The information that we have here are as follows. We know that n is equal to 8. And we have mean 35.5. And standard deviation is also given to us as 7.2. Our goal is to construct a confidence interval for the mean. So we have to follow the steps. N is 8, but we know that the population is normally distributed, so we're happy about that. I have to mention all of the steps. It's normal. Okay, so what is your point estimate? Point estimate, x bar is the mean, 35.5. Now C is equal to 95%. What is ZC?
Professor, you're blurry again.
So for 95% confidence level, what is ZC? 1 point? 1 point?
1.96.
96. Thank you. And what's the margin of error? ZC times sigma divided by square root of n? Yes? No? What is this SC? Is it your sigma or is it your S? Take a look at your question. Information about sample is given. So it means that we have TC, not ZC. What is TC? The degrees of freedom is 8 minus 1, which is 7. What is your TC?
$2.365.
Thank you very much. So your E is TC times S divided by square root of n, 2.365, and S is given as 7.2 divided by square root of 8, which is approximately equal to
6.02.
6.02. And now confidence interval is equal to x bar minus margin of error, x bar plus margin of error. So your x bar is equal to 35.5 minus 6.02 and 35.5 plus 6.02, which is approximately gives you 29.48 And let's see here, we have 2, 5, 41.52. So we are 95% confident that the population mean is in between 29.48 and 41.52. Let's take a look at question 6. Question 6 says, hey, you had a survey of 2,000 adults and 1,073 of them think that there should be more government regulation of oil company. Construct a 95% confidence interval for population proportion, and the second one says find the minimum sample size needed to estimate the population proportion if your confidence level is 99% and the margin of error is 3%. So let us write down this information on the board. Perfect. So here I have n equals to 2,000 and x is equal to 1,073. And our goal is to construct a 93% confidence. Interval, this is part A. Part B says, what's the sample size if margin of error is 3% and C is 99%. Very well. Let's get back to the board. Okay, so here we have n, we have x. It means that we can find our point estimate, which is the proportion. P hat is 1,073 divided by 2,000, which is approximately equal to, what is your P hat?
.54.
0.54, approximately 0.54. Thank you. So now n P hat is greater than equals to 5 and Q hat is greater than equals to 5. Remember that Q hat is 1 minus P hat. So your Q hat is 46%. Now we're going to find the critical value. We know that C is equal to 95%. It means that ZC is 1.96, and then E margin of error is ZC times square root of P hat Q hat over N. Approximately, it is 1.96 times square root of P hat, which is 0.54 times 0.46 divided by N, which is 2,000. So what is our margin of error?
.02.
0.02, thank you, 0.02. So you can say that, hey, the confidence interval for 95% confidence level is P hat minus E and P hat plus E. Well, we found P hat, which is 54%, 0.54 minus 0.02 and 54% plus 0.02, which is approximately is equal to, let's see, 0.56 and if 0.52. So what is N? N is equal to, how do we calculate N? Remember that you can use the formula for your margin of error to find N. You can write E divided by ZC and then flip it and get ZC divided by E squared times P hat Q hat. So this is approximately ZC is 1.96 divided by E. Margin of error is given to us in the question, 3% squared times P hat, Q hat, 0.54 times 0.46. So we have to round it up. It's going to be 1,832. Minimum sample size. To get a confidence level of 99% with margin of error of 3%. So let us take a look at question 7. Question 7 says, hey, you have this information, you have a sample. Well, we have a sample. And the information given to us are as follows. Assume the population test score are normally distributed and population standard deviation is given to us, 103. So this is question 7. Okay, here we go. N is 12. And standard deviation of the population is given to us as 103. And we want to find a confidence interval with 90% confidence level. And finally, part B says, determine the minimum sample size required to have 95% confidence with 10 points of population mean test score. So here we have C equals to 95% for part B, and the margin of error is 10. Let's take a look at the question. Here we go. So N is 12. A standard deviation of population is given to us. This is sigma. So sigma is given to us. We're happy about that. We just need to find ZC, not TC. So to find the confidence interval, first of all, N is 12, but the question says the population is normally distributed. So we're happy about that. Is normal. Now, what is our point estimate? What is X bar? When you calculated X bar, what was the X bar? 662.5. Very good. 662.5. Very well. So confidence level is 90%. ZC is equal to 1.6. What is your ZC? For 90% confidence interval, your ZC is
1.645.
the rest of the class. Thank you so much. 1.645. Thank you. So margin of error is equal to ZC times sigma over square root of N, 1.645. Sigma is 103 divided by square root of N or square root of 12, which is approximately 'What's your margin of error, guys? I'm waiting on you.
$48.91.
Very good. 48.81, 91. I have different numbers in the chat.
48.91.
91, okay. So your confidence interval is equal to X bar minus margin of error and X bar plus margin of error. So approximately X bar, here you have 62.5 0.5 minus 48.91 and 662.5 plus 48.91. Approximately, the confidence interval that you get is 613 and 711. Perfect. So we are 90% confident that the population mean is in between 613 and 711. Not the store 711. Perfect. C is equal to 95%. E is 10. We want to find the minimum sample size. To find minimum sample size, remember that we're just exactly using this formula. We flip it and we get rid of the radical. So here you get n equals to sigma over E squared times ZC. So your ZC is 1.645, sigma is 103 divided by 10 squared. The minimum sample size, if you do the calculation, is rounding it up 408. This is the minimum sample size that we need. And this is squared as well. Okay. Don't forget to square it. So let us move on to the next question, the last question. Yes.
I have a question.
Go ahead. Thank you. So yes, guys, this is 95%. This is 1.96. Thank you so much. Perfect. So question 8 says, you work for a consumer advocate agency and want to estimate the population mean cost of replacing a car's transmission, okay, as part of your study. You randomly select 50 replacement costs and find the mean. Okay, here we go. This is question 8. Let's write down the information here. N is 50, and we found that the mean is 2,650. And what else do we have here? Okay. And assume that population standard deviation is given to us. So a standard deviation of the population is $4.28, $425. Okay, perfect. Construct a 95% confidence interval for population mean. What is CI? Let us finish this one as well. So sigma is given to us. We're happy. We just need to use ZC. Remember that n is greater than or equals to 30. We don't need the population to be normally distributed. So C is equal to the confidence level is 95%. Okay, perfect. It means that ZC is 1.96. Very well. So to find the margin of error, we have ZC times sigma over square root of n. Remember that the standard deviation of population is given to us, which is approximately 1.96, 425 divided by square root of 50. What do you have approximately? What is the margin of error? $117.8. Thank you, Myra. Thank you, Selena. Excellent. Now, to find confidence interval, it is x bar minus e and x bar plus e. What is x bar? X bar, or point estimate, is the mean of your sample. So approximately is 2,650 minus 117.80 and 2,650 plus 117.80. So the confidence interval that we have is 2,532 approximately and 2,767. We are 95% confident that the population mean cost is in between $2,532 and $2,767.